Hi everyone, earlier in the lesson you've been learning about the different ways that energy can be stored or transferred. An energy store is one where an object has energy within it, so it's got the possibility to do something. Here are the main energy stores. If you've got a battery, then that battery's got a chemical energy store. The energy will be stored in the battery until we choose to turn whatever it is on. That's when the energy will be transferred out of the battery, or essentially it will leave the battery to then go to do something else. Another example of an energy store is if you've got a thermos bottle. Anything that's hot will have energy stored as thermal energy. By keeping your hot drink in your water bottle, you're able to keep that energy stored in the liquid rather than it getting transferred into the surroundings. This is another energy store, although you probably can't tell what it's supposed to be. It's meant to be one of those jack-in-the-boxes where you've got like a weird little puppet thing and it's on a spring and you squash the spring down and then you turn this little handle and eventually this little jack-in-the-box pops out and gives everyone a shock. Anyway, the fact that you've had to originally squash this jack-in-the-box into the box and you're squashing the spring means that this has elastic potential energy, because until the spring is actually squashed, then nothing can happen. Elastic potential energy is when you either squash or stretch something, which can go back to an original position. Another example would be that if you've got a slingshot and you pull it backwards, when it's all floppy, it can't do anything. It's got no potential to do anything. But then when you stretch it, it means that there's the possibility of letting it go and making something else move. It would be the same if you stretched an elastic band or if you stretched a spring. The fact that you stretched it means that it can bounce back to its original position. That means it's got elastic potential energy. Next, we've got a roller coaster, and this was to demonstrate two different types of energy store. Firstly, whenever you pick anything up from the ground, it's got the potential to drop. That is known as gravitational potential energy, otherwise known as GPE. Anything that's raised up off the ground has got GPE. For example, if you've got a ball hanging on a piece of string and you're to lift this back, so it's starting here, it now has the possibility to swing, which it didn't have before. As we moved it up, it gains GPE. When something gains GPE, it's almost always linked to kinetic energy. Kinetic means to move. So once you've gone to the top of your roller coaster, once it starts to go down, that gravitational potential energy is now becoming kinetic energy. Once you start falling, you're going to start losing some of the height you had before. So your GPE is becoming kinetic energy. By the time you've got to the bottom of your roller coaster, you're going to be going really fast, but because you're at the ground, all of that energy will have been converted to kinetic energy, and some of it will have been lost as heat and sound, and you'll have no gravitational potential energy anymore. There are a few other types of energy stores. For example, energy stored as electricity, which you'll find in thunderstorms or static electricity. There's magnetic energy, which I wouldn't really worry about at the minute. And there's also nuclear energy. We take advantage of nuclear energy when we use it in power stations. And there's energy stored within the atom, and those atoms can be broken or split apart. And as the atom gets broken apart, the energy is released and we can use that energy in useful ways. We rarely actually want to keep the energy locked up in the store. We want to use it somehow or transfer it. So the energy can either be transferred to another object or it might be transferred to the surroundings. If you think about our hot water example, at the moment the water is hot, but it's going to start being transferred out of the water as heat. As it does, then the surroundings get warmer and the hot water gets cooler. If you think about the jack-in-the-box, we had the energy stored as elastic potential energy. It was squashed. Once we open up the box, the elastic energy is sort of released or transferred because of the push of the spring. So it's a mechanical transfer. That energy then becomes a kinetic energy store. If we have a look at the battery, you can imagine a torch. The energy starts stored in the battery as chemical energy. From the store, the energy needs to be transferred to the bulb, and that happens as electrical energy. Once the electrical energy gets to the bulb, it's then going to be transferred to the surroundings as light, although some will also be lost as thermal energy, as you'll always notice that lights tend to get a little bit warm. What we've just drawn over here is known as an energy transfer diagram. Energy transfer diagrams show how energy can be moved from one place to another. They also show whether the energy is being stored or whether it's being transferred. We usually draw energy stores in a box and energy transfers over arrows. Let's have a look at another example. Imagine you had a load of wood. Wood is a store of chemical energy. Once we light the wood, energy is transferred to the surroundings as light and as thermal energy. We could also draw an energy transfer diagram for our roller coaster from before. We'll start at the top of the roller coaster. At the top, the roller coaster has lots of gravitational potential energy. Once the roller coaster starts to roll down, that gravitational potential energy will be transferred and stored as kinetic energy as it starts to move. But the more it moves, the further from the top it gets, so the gravitational potential energy starts to decrease. Eventually, all of that gravitational potential energy will have been transferred into a kinetic energy store. A tiny bit will have been lost as heat. That always happens. Whenever there's an energy transfer, some of it will be lost as heat. If that roller coaster then starts to go up again, that kinetic energy store is converted back into gravitational potential energy. Because the total amount of energy in the whole universe never changes, as the gravitational potential energy goes up, kinetic energy will go down by the same amount. And when kinetic energy goes up, gravitational potential goes down by the same amount, except for those tiny bits that are lost as heat. We can draw these energy transfer diagrams for anything where energy is being transferred. In your diagrams, make sure it's clear where the energy is being transferred from and to, and also make sure that you include the name of the energy transfer or store. Let's go now with some of your own examples.